input side, you have a resonant capacitor, and you have a hybrid transformer with its primary and a secondary, and you have a diode, and on the output, secondary delivers current to the load. You see also here waveforms. Just to tell you what is new, as I said, now with the switch mode power conversion, we are in charge of the circuit configuration. And we are in charge of everything extra which is put around that transformer to make it a transformer. Now you see one transformer that I made for the first time, which operates with a square wave voltage or rectangular voltage drive across from input across the whole windings. So therefore there is a square wave voltage drive imposed here, but unlike this square wave current in a isolated Chuk converter, now I have a current in the primary, this diode current, you see the diode current that is shown in yellow. You see that yellow? That is a diode current and operated 10% duty ratio, say. This switch is operated on and off, 10%, 90%, okay? So this is a charge and this is a discharge. Then the point is that this diode is now sinusoidal current. You see that? It's sinusoidal current, which has an average of 15 amps. But time domain, actual time domain in this diode current is a 30 amp peak to peak, but 15 amps is a current in the load, okay? And how is this diode current split? It's split between the primary of this, what I call a hybrid transformer, which primary is a red waveform. And you see red waveform has a zero average. That's a current which has a zero average. It must, because the current, this capacitor is having charge and discharge and cannot have a DC current in it. So therefore, this is a AC current. It is sine wave current. So you are driving this transformer from here to here with the square wave voltage that you see here, but the current in the primary is a sine wave. And what is the current in the secondary? Current in the secondary is whatever turns ratio is to step down the voltage. This is now step up a current. If it is 2 to 1, step down in the voltage is 1 to 2 step up. So this current is now twice larger. And what is then sum? This current and this current in secondary who are split, the two together, these two currents result in a diode current which is at zero level. And why that is important? Because now this shows that this diode operates at zero current mode. At any point, at turn on and turn off, this diode is at zero current level. So there is no switching losses associated with it, only conduction losses. And the other important feature is, if I show you in a second, if I drive this, not with the 15 amps, but let me show you here when it changes. Okay, you see, I changed now current from 15 amps, I changed it to 7.5 amps. You see here? You see, I changed it to 7.5 amps and see what happens. 7.5 amps. 7.5 amps. And you know what? 7.5 amps. So it is half of the DC load current. So you will see now on the top channel that 15 amps will reduce down to 7.5 amps. Yeah, okay. So you see here, when I reduce. You see my point? The converter is not a voltage to voltage converter. It is voltage to current converter, where the current on the output of 15 amps dictates peak to peak current drawn from a diode. If this is what you need for to have a fast transient for a microprocessor drive on 1 volt going from 100 amps down to 20 amps. Yes, it never changes mode of operation. It can operate with no feedback. It operates 99.5% efficiency, and it has everything in a single converter. Operating 100 kilohertz, has a fast transient. It doesn't need a 12 buck converters and 12 magnetics. It has only one magnetic, okay? And what is the other point is, you notice that if I have this resonance is just a half of off-time interval, if I now make two identical converters in parallel, they will share the DC current, and one will have a 7.5 amp and the other will have a 7.5 amp, but what will happen? This, the ripple currents will be directly out of phase and cancel. Isn't that beautiful? That now I have a capacitor on a secondary, which is nothing, and yet it has a constant current, and it changes abruptly. Whatever current on the secondary says, it drives the magnetics in such a way to draw the current in the next cycle, whatever is needed. It never goes into negative part. This is zero switching losses and have a zero ripple on the output, literally. And the only capacitor on the input is reduced in the size by turns ratio. If this 10-to-1 turns ratio, this capacitor is having 10 times smaller current. This is 100 amp. This will see only 10 amps on input. So everything is there. So question is, why they're not using it? Because
the current,
they don't want it. Actually, I had it already licensed on one company, and not to name it, and they after my exclusivity expired, I canceled exclusivity, and I'm now looking for other companies to license it and to really meet the demands of this $10 billion market that everybody who has microprocessor needs the drive. And this, of course, has a much better, performance and much lower cost, much lower losses, and much better performance as far as step load change and size of the capacitors that's needed. Okay.